This is part 2 of Unit 4, Lesson 3, Related Rates, Rates of Change of Other Applications. We're starting with Example 4. So going back to Example 3, because this is related, it was about headphones, and we had a cost function, C of x was 1500 plus 50x plus 0.01x squared. We were producing Bluetooth headphones, and we talked about cost and marginal cost in example 3. That's in the first video if you want to review it again. So suppose now that we are going to sell those headphones for $120. So we want to write a revenue function. So our revenue function is going to be R of x is going to be what we're selling the headphones for times the number of headphones that people buy. So the profit function is going to be, from on the front page, pi of x is our revenue minus our costs. So in this case, our pi of x is going to be 125x minus our cost function, which is 1500 minus 50x plus 0.01x squared. So simplifying this, we get a profit function of negative 1500 plus 75x minus 0.01x squared. Okay, so we're supposed to find the marginal revenue function. So just like marginal cost, our marginal revenue is going to be the derivative of the revenue function. And in this case, it's going to be a constant. So we're supposed to compute the marginal profit function if 100 sets of headphones are produced and sold, and interpret our function. So if we want marginal profit, again, when we're using that word marginal, we're going to use the derivative. So we're looking for pi prime of x. So when we take the derivative of our profit function, we're going to get 75 minus 0.02x. Now we want to know what our profit margin is, our marginal profit, if we produce 100 sets of headphones. So we're just going to substitute 100 into our function, and we get pi prime of 100 comes out to be 73. So what does that mean? That means that when 100 headphones are produced, I should put and sold now because we're talking about profit. And sold. The profit is increasing because it's positive. At a rate of $73 per headphone, or per set. Okay, so next, how many headphones should the company produce in order to maximize profit? So the profit will be a maximum where pi prime of x equals 0. So we're looking for a horizontal tangent line. So taking the derivative of our profit function, which we already did, we want to set 75 minus 0.02x equal to 0 and solve this. So we're going to have 0.02x equals 75. So x is going to equal 3,750. So the profit is maximized when 3,750 sets of headphones are sold. Manufactured and sold. Okay? Because you do get to a point where, those who have business classes know this, that you can overproduce and then you end up pricing yourself out and you're making less profit on each headphone. Okay, next. So let's take a look at this graphically, our marginal cost, revenue, and profit. And this is a very nice picture here. So in the graph, notice the break-even points occur where revenue equals cost. So they're marked there. And so right here and right here, we have revenue, and which is the parabolic curve, and our cost function is, in this graph, a linear curve. So those two break-even points. A company would obviously be most interested in knowing how to maximize profits. So that occurs where marginal cost equals marginal revenue. Okay, those are break-even points. However, maximum or minimum profits do not necessarily have to occur where MR equals MC. They can also occur at endpoints. Consider the slopes of the tangent lines then when the marginal cost is less than the marginal revenue. A company will spend more in extra revenue than it will make more in extra revenue than it will spend in extra costs by increasing the profit. So you can also see the biggest difference between those curves as well is where you will maximize your profit. Okay, so using this idea, let's look at example 5. So example 5 says an office supply manufacturer produces spiral notebooks for interactive student notebooks. Find a quantity X that maximizes profit if its total revenue, R of X, and its total cost, C of X, are given by these two functions. Okay, when we're only producing up to 1,000 notebooks. What production level gives the maximum profit? Okay, so what we want to find is the derivatives of both our revenue and our cost function. Because remember, where marginal revenue equals marginal cost. So that's what we're looking for. Whoops, sorry about that. Where MR is equal to MC. So that means that those are our derivatives. So let's find our derivatives. So R prime of X is going to equal 8 minus 0.008x, and C prime of X is equal to, it's a constant, 1.2. So as I was saying, we're going to maximize our profit where R prime of X is going to equal C prime of X. So we're going to go ahead and set those equal to each other. So we have 8 minus 0.008x is going to equal 1.2. Solving for x, we're going to get 0.008x equals 6.8. And so when we divide this, we're going to get 850 notebooks. That's where we're going to maximize our profit out of. We have the capacity to produce 1,000, but our profit will be maximized at 850 notebooks. Okay, so we could do a quick check here. And how we can do that is we can check what happens at X equals 849 and X equals 851. Because we're going to look at the difference in producing and our profit in those two. I wrote it again, 851. That should be a 1. All right, so for 849, our marginal revenue is going to be 8 minus 0.008 times 849. Putting that in our calculator, we get 1.21. And then for 851, our marginal revenue is going to equal 8 minus 0.008 times 851, and we get 1.19. Now, the thing is, our marginal cost is a constant, so we don't really have any calculations to do for that. So what we're really looking for is to see that at 849, our MR is 1.21, and that is greater than the 1.2 for the marginal cost. At x equal to 851, and I'll write the 1 this time, we have a marginal revenue of 1.19, and that's less than our marginal cost. So the better value is at 850. And so that's how we know we have maximum production at 850 notebooks. Okay, I'm going to stop this video here, and in the third video we will finish our last 3 examples.